In chapter 3, we're going to look at probability distributions, how to fit probability distributions and understand the different kinds of probability distributions that are available as part of at-risk platform. Okay, here, fit probability distributions to empirical data. So you have empirical data that you have observed, and then you fit a probability distribution. So at-risk is going to give you a list of theoretical probability distributions in the order of how well they fit to the empirical data. Okay. So the best one, the second best, the third best, and fourth best. But by best, we need to be very careful, because best here is about how closely the theoretical curve fits the empirical data. Sometimes the one that fits the empirical data closely may not be the best or the ideal probability distribution to use, so you have to be careful about that, and we'll discuss that as well. And then, of course, we have two categories of probability distributions. There are a bunch of discrete probability distributions that are available in at-risk platform. We'll look at those, and then we will look at continuous probability distributions. Okay. And with these concepts under our belt, so we are going to look at two cases in this chapter. The first case is Facebook valuation case. So here we're looking at the income statements, the financial statements of Facebook prior to the time when they were going to go public. Okay, so we have like 5 or 6 years worth of data, and we have macro level data like revenue, cost of goods, and gross income, and other expenses, and so on. And so we're going to set up a deterministic model first to project from the current, based on the 5 or 6 years of past data from the financial statements. We're going to project what will happen for the next 10 years. Okay, and we will make some assumptions about those costs, and then we will use an expected net present value, and then use that for valuation. Okay. Then once the deterministic model is set up, then we will revise the model with at-risk functions for uncertain input variables. There are 3 uncertain input variables that we'll be looking at. For each of them, we'll incorporate at-risk probability functions, and then we will run simulation replications and then review the results. So that will be what we will do for the first case, which is the Facebook valuation case. And then we're going to look at value at risk case. So this one is from using hypothetical data, and this is about what would be, if you invest say $100, what will be the value of that $100 after a certain passage of time. Say after then, tomorrow what would it be worth, or in 5 days what it will be worth. So that's what we're going to be looking at in this case. And here what we're going to do is, first, of course, obviously we set up a deterministic model, and then we will use what is called the Bootstrap method to simulate 5-day return. Okay, so there is a Bootstrap method available in at-risk. We'll talk about what that is, what Bootstrap is, and how do you incorporate that in the simulation model. Then, of course, we'll run the replications and then review the results. So we look at probability distributions, and we look at the Facebook case, and then we look at the value at risk case in this chapter.